guys, welcome back to the shop. Frank here. We're working on the Cub Cadet Mini-Dozer. We've got a significant improvement to it to increase reliability and strengthen the axle arrangements. I'm getting ready to cut out some parts for the outboard axle supports. The first piece here is a component. It's going to be made up of several plates welded together. It's basically the standoff from the track frame that'll then support the axle braces, which will, have the bearing housings that will support the outboard idler and drive sprocket spindles. So this is the beginning of the effort to reinforce the wheels on the dozer. As we noted earlier, the idler wheels and the sprockets are spaced off of the axle, the Cub Cadet axle hubs, by 4 inches, and that puts an additional moment arm on the. That's my refrigerated air dryer. Puts an additional stress on the axles. So this will be a brace assembly that will attach to the side of the track frames, and will have arms, plates which carry bearings that will support the outboard ends of the axles. So we're going to cut out some parts here on the plasma table and begin assembly of these parts. This is going to take a couple episodes to build this. It's a pretty complicated arrangement, but we'll get started here with cutting out some parts for the first of 2 axle support assemblies. All right, the plasma cutter did a nice job on all these parts. A little bit of dross on the back, some of these, but I think that'll come right off. All right, we'll go over to the welding table and look at how these parts will be assembled. All right. We're basically going to build a box beam, and so because I don't have a C-channel that is the appropriate size. What I need is a C-channel which will stand off of the frame about 3 inches and be about 3.5 inches wide. And we'll then, this particular component would be welded to the box beam and would have bolt holes in it. I think I'm going to weld nuts to the inside of it to support the actual plate that will have the bearings on it. So we start with 2 sides. So these 2 sides, they're not going to be right angle sides. They're going to be tilted slightly, and that's to give them some rigidity. Alright, so you can see here that this beam will be, it's like a C-channel, only it'll be trapezoidal. Now these are not symmetric, but maybe closer to that. So you'll see it's a trapezoid shape. These 2 long edges that are on the table would be welded to the track frame, and then our support for the axles would attach to the face of this and extend this way and have a bearing to support one axle, and it would extend out the other direction with the bearing to support the other axle. And this is a beam, a C-channel basically, that will get welded to the track frame. So I need it to stand off 3 inches away from the track frame. It allows me to extend the support plates with the bearings on them off to in each direction. All right. Maybe a little bit hard to explain or understand, but you'll see what happens here when we get to the next step. We'll tack this up and attach it or test fit it to the track frame and see what that looks like. All right, so I totally suck as an artist, but let me show you what I'm going to try to do. And I'm not sure this is going to work, so you can follow along on this adventure, which may or may not pan out. We're going to give it a shot. All right, so I have 2 wheels. One's actually a sprocket, but it doesn't matter. And we've got the track frame that goes between them. So I'm building this channel which will fasten to the track frame. And then I'm going to make 2 plates. One will go like this, and basically around and then back. And then I'll put a bearing on that plate and it will capture that shaft, and then it will be bolted to this channel. And then I'll have another plate which will basically do the same thing on the other wheel, a bearing, capture that shaft, and be bolted to this channel. And I need the channel to space it away from the track frame so that, you know, there's space for the lug nuts that are on the wheel as well as the tensioner. And actually the channel will stop there. The tensioner comes down and tensions the, you know, the upper wheel. So I'm struggling with making sure that these 2 bearing plates, the one that goes here and the one that goes over here, are rigid enough. I'm going to cut them out a 3/8 inch plate, and I'll likely weld a stiffener down the center of each one. I'm going to see how rigid they are, but likely going to require a stiffener. I'm not sure yet. And the reason it's arranged like this is so that I can remove them, of course, and, you know, so I can get the wheels off. Obviously, you need to be able to do that for service. So that's what we're building, and the 2 things I'm going to cut out are these 2 bearing plates. There's a long one and a shorter one, and not really shown on here. One's longer because it has to reach past the tensioner arm. And, you know, the bolts for that one are a little bit further away from the hub because of this tensioner arm, but that's, you know, I can't really do anything about that. So at least they'll provide some support. Whether they'll be effective or not, I'm not sure. All right. So that's where we're headed. We're going to cut those parts out. We'll see where we go from there. And of course, who comes in here but Mr. Brutus. Coming in again for some hugs and snugs. Yeah, you're a good boy. So what you guys don't see is that he comes in about every 10 or 15 minutes all day long. Gets a little bit of affection. One guy commented on the channel that he's coming in checking on me to make sure I'm safe. I don't know if that's true, but could certainly be. But he also comes in to get some attention. He's such a sweet dog. Find the center. I've already marked this with a scribe for the center. And the exact location of the center on this disc is not as important as the center relative to the bolt circle, which we're going to drill around here. So locating the center this way is plenty accurate for this purpose. So once we get the center hole established, then we'll set the DRO and zero out the X and Y axes, and then use the XY coordinates to locate the other 5 holes for the bolt circle. So that's what we're going to do. And start the mill. Yeah, so that's real close. So I'm going to go ahead and drill this first with the 5/8. All right, so let's go to the rest of the bolt circle. Got the DRO set. And we're going to go to Y is 0, X is 2.25. All right, so we're going to come back to 0, 0. And increase the center hole size to 1 inch. All right, so there we are, 0, 0. Getting a lot of chatter. This is not the most rigid setup, but short of you know, swapping this out for a rotary table, and even then might not be any more rigid, holding it from the outside edges. But anyway, this is sufficient. All right, so this will give us we need for the idler. All right, so that'll give us a place to put the shaft. All right, so we will eventually weld this, get this straight, and weld it. We'll do the same thing on the other, on the sprocket. Is that my brew coming in? Yeah, what a good boy. What a good boy. Yeah, you're my good puppy. You're my good boy. Yeah. Looks like you lost a white whisker. You had 2 white whiskers. You had 2 white whiskers on your nose, and now you only have 1. We were getting ready to call you White Whisker. So now you only have 1 white whisker on your nose. You must have lost the other one. Yeah, you're such a good boy. Yeah. So is Butchie outside? Is Butchie outside? Is Butchie outside? Huh? You don't care. You don't want to know. You don't want him in here anyway. Give me that paw. Give me that paw. Give me that paw. Give me that paw. Yeah. That's a good puppy. That's a good boy. Yeah. You're my good boy. All right. Going back outside to harass Butchie. The 2 of them chase each other all over the place. It's fun. It's so funny to watch them play games. They like crouch and try to engage the other one in play, and then they chase each other, and then sometimes Butchie will get, he's the bigger dog, he will get Brutus to lay down, turn over, expose his stomach, basically submit. And then there are other times when Brutus gets Butchie to submit. And I read where in play, dogs, and I guess other animals too. I think the study was done with other animals as well. But anyway, with the dogs, if the dominant animal doesn't let the subordinate animal win at least 30% or 40% of the time, they'll quit playing. So in order to continue to play, which they both want to do, the dominant dog has to let the subordinate dog win at least 30% of the time. And yeah, with these two dogs, it seems like it's almost 50-50. And here comes Brutus again. What are you looking for, Brew? Huh? Are you just looking for some loving? Yeah. Yeah, you're such a good boy. You're such a good boy. Butchie must be out there lying in the sun. It's kind of a nice day, about 50 degrees, 55 degrees. Early March. What, March? March 2nd, matter of fact. Yeah. So, good boy. All right. Next thing we're going to do is cut out the bearing plates on the plasma table. Maybe I can... So that's how you get a 375-pound sheet of steel on the plasma table. All right, it's a little awkward, but doesn't really require having to lift it yourself, so it works. All right, that's a piece of 3/8 inch. I'm going to use that to cut out the bearing plate arms. All right. We'll come back, we get the table full and the air system charged up. Here's the arrangement, the way it's going to be for the bearing plates. So we'll have a bearing, a flange bearing here, bolted, I'll have 6 bolts, and I have this on here just as a weight because this is cantilevered off the end and is tipping. So that's just a weight on there to hold it. Move it there. So 6 bolts here, and that'll engage the front wheel, that bearing, and then 6 bolts here, and there's room here for the tensioner arm to go up and swing up and down, and then bolts for the for the bearing, flange bearing for the rear wheel. So this whole arrangement will get attached to the horizontal track frame, main track frame beam here. All right. I mentioned that I felt like I needed a different cylinder for the tilt cylinder on here. So this cylinder here just seemed too short, and I purchased a larger cylinder, but in looking at it, I don't think that will solve my problem. My main problem is interference between the anti-sway brace and the back of this blade mount. So I'm looking at a solution for that. There's a couple different ways I can do it. I can move this brace to this arm and brace it this way, which will work fine, and we'll move the brace out of the way of this. So that's at least one thing I could do. Looking at a couple other solutions, so I've got to think about that some more. So I really haven't come to any decision on what I'm going to do there. I mean, I can use it the way it is. It works okay. It's just not as easy for me to raise the blade when I back up, but I can raise it, so it's just not as much as I would like. I don't know whether I need to mess with it at this point. It's kind of become a lower priority on my list of stuff to do. I want to work on the outboard axle supports, which is what, you know, we're working on now. All right, so we'll come back next week and work some more on the outboard axle supports, the bearing plates and sort of thing. See if we can make some progress on that. It's going to take a couple episodes to get that built and installed. We'll see how it works. All right, thanks for watching. If you haven't already subscribed, go ahead and subscribe if you want, so you can keep up with upcoming episodes, and leave a comment if you have any suggestions. I'm certainly open to them. We'll see you guys next time.